close your eyes for a moment and imagine the universe. Stars twinkling, galaxies swirling, planets rolling endlessly around their suns. Even at the smallest scale, deep inside atoms, tiny particles spin with restless energy. It seems as though the entire cosmos is caught in an eternal dance. But have you ever wondered, why does everything spin? Why is motion, rotation, and swirling such a universal rule, from the tiniest particle to the grandest galaxy? That's the mystery we're about to unravel. And trust me, by the end of this journey, you'll never look at the sky, the earth beneath your feet, or even the air you breathe in quite the same way. If you love exploring the hidden rhythms of the cosmos, stay with me till the end. You're about to discover why spinning is the heartbeat of the universe itself. The first twist in the universe. To understand why everything spins, we need to travel back, not just thousands or millions of years, but to the very beginning of time. Picture the universe compressed into something smaller than a grain of sand, then erupting in the grand event we call the Big Bang. That explosion was not smooth. It was messy, imperfect, filled with tiny ripples and clumps of energy. And inside those imperfections lay the seeds of rotation. As matter scattered and clumped, it didn't stay still. It twisted, swirled, and began to move. That first cosmic turbulence planted the motion we still see today. Here's the important part. In space, nothing presses pause. There's no friction, no brakes, no invisible hand to stop the motion. So once something begins to spin, even if it's just a slight nudge, it can keep rotating for billions of years. What began as a whisper of motion at the dawn of time became the grand cosmic dance of galaxies, planets, and atoms. The cosmic law of motion. But why does spin survive? Why doesn't the universe simply slow down? The answer lies in one of the most important principles of physics: the conservation of angular momentum. It sounds complicated, but the idea is beautifully simple. Imagine an ice skater twirling. She starts spinning with her arms stretched wide. When she pulls her arms close to her body, she spins faster. When she spreads them out again, she slows down. No one is pushing or pulling her. It's simply the law of motion redistributing itself. The universe works the same way. When giant clouds of gas and dust collapse under the pull of gravity to form stars or planets, they naturally spin faster, just like that skater pulling in her arms. The spin doesn't come from nowhere. It's conserved, reshaped, and amplified. That's why planets rotate. That's why stars spin. That's why galaxies swirl. Atoms, the microspin. Now let's shrink ourselves down, way down, past the level of mountains, cells, and molecules, down into the invisible kingdom of atoms. Here too, spin rules everything. Electrons whirl around the nucleus, not in perfect orbits like tiny planets, but in strange, fuzzy clouds of probability. And beyond this orbital motion, there's something even stranger. Electrons, protons, and neutrons carry a fundamental property called spin. This spin is not like a basketball twirling on your finger. It's quantum in nature, an intrinsic kind of rotation that defines how particles behave. In fact, the entire chemistry of life, how atoms bond, how molecules form, how signals fire in your brain, depends on the mysterious spin of these subatomic particles. Without it, there would be no chemistry, no biology, no you. The universe is built on spin, right down to its most fundamental bricks. Planets. A solar ballet. Now let's zoom back out. Step into our solar system, where planets perform their grand ballet around the sun. Every world spins, but each with its own unique rhythm. Earth spins once every 24 hours, giving us day and night. Jupiter spins so quickly that one day there lasts less than 10 hours. Uranus spins sideways like a barrel rolling through space. And Venus spins so slowly and in reverse that one day is longer than an entire Venusian year. None of these rotations are random. They are inheritances, gifts from the swirling cloud of gas and dust that collapsed to form the Sun and its family of planets. As gravity pulled the solar nebula tighter, the whole system began to rotate faster. Each planet picked up its own spin, later shaped by collisions, cosmic impacts, and billions of years of orbital evolution. So when you see the sunrise tomorrow, remember this. You are standing on a giant stone sphere hurtling through space, spinning at over 1,000 miles per hour. And you don't even feel it. Stars and galaxies, the giant whirlpools. But the story doesn't end with planets. Stars themselves spin, sometimes calmly, sometimes ferociously. Our sun makes a full rotation about once every 27 days. Massive young stars, blazing with heat, can spin dozens of times faster. Now step even further back. Imagine entire galaxies, collections of billions of stars, swirling like whirlpools in the cosmic ocean. Our Milky Way galaxy spins at about 1.3 million miles per hour. Yet even at that speed, it takes 200 million years to make a single rotation. Since Earth was born, our solar system has only traveled around the galaxy about 20 times. Why do galaxies spin? The answer, once again, goes back to the beginning. Ripples of matter in the young universe collapsed and twisted under gravity, creating immense spirals. Those first swirls never stopped. They became the breathtaking spirals we see scattered across the night sky. The spin that shapes everything. Here's the secret. Spin isn't just a byproduct of motion. It's the very architect of structure. It's why Earth bulges at the equator. It's why hurricanes spiral. It's why electrons pair up and atoms build the molecules of life. It's why black holes twist the very fabric of space-time around them. Spin is the rhythm of the universe. Without it, there would be no galaxies, no planets, no storms, no atoms, no us. The universe doesn't just exist, it dances. And every part of it, from the tiniest electron to the largest black hole, is caught in that eternal spin. When we think of spinning, our minds often go to planets, stars, or galaxies. But rotation is not just a cosmic trick. It's something we can see and feel all around us. Look at Earth's atmosphere. The spin of our planet shapes the winds, the weather, and even the flow of oceans. Take hurricanes, for example. These massive storms don't just form out of chaos. They are born out of the planet's rotation. The Coriolis effect, caused by Earth's spin, makes storms swirl into spirals. In the northern hemisphere, they twist counterclockwise. In the southern hemisphere, clockwise. Without Earth's rotation, hurricanes and cyclones as we know them wouldn't exist. Even the gentle trade winds guiding ancient sailors across the seas were shaped by the same invisible hand of planetary spin. And it doesn't stop there. Ocean currents, too, are set in motion by the rotation of our world. They distribute heat across the globe, turning Earth into a habitable planet instead of a frozen wasteland at the poles and a scorched desert at the equator. Once again, spin is the architect of balance. Everyday echoes of cosmic spin. But let's leave the skies and oceans and turn inward. Spin is not just something out there in space, it lives inside us too. Your very body is a masterpiece of spin. Electrons spinning inside atoms shape the chemistry of your cells. The magnetic field that protects you from solar radiation is powered by Earth's rotating iron core. Even your inner ear, the part that gives you balance, is sensitive to spinning. Try spinning yourself in circles. You'll quickly feel your equilibrium collapse. That dizziness is your body's reminder that you are part of a spinning world. The act of spinning fascinates us on every scale. Children twirl in play. Dancers pirouette. Athletes spin balls with perfect precision. From amusement park rides to spinning tops, humans mimic what the universe does naturally. Perhaps, deep down, it feels familiar because we're echoing the same laws that shape the cosmos. Spin as energy. Spin is not just motion, it's energy. Whenever something rotates, it carries kinetic energy. Engineers harness this principle every day. The turbines that generate electricity spin with the power of wind or rushing water. The hard drive in your computer stores data by spinning at thousands of revolutions per minute. Even the technology of the future relies on spin. Physicists are exploring spintronics, a field where the spin of electrons, rather than their charge, is used to store and transmit information. This could revolutionize computing, making it faster, smaller, and more efficient. Imagine that the same quantum spin that shapes atoms could one day power the next generation of human technology. Black holes, the extreme spin. If you want to see spin taken to its most extreme form, look at black holes. These cosmic monsters are born when massive stars collapse under their own gravity. But they don't just collapse, they spin, often at nearly the speed of light. A rapidly spinning black hole doesn't just trap light. It twists the very fabric of space-time around it. Astronomers call this effect frame dragging, as if reality itself is being pulled into a whirlpool. Matter falling into the black hole doesn't simply vanish. It swirls around in a hot, glowing disk, spinning faster and faster, before crossing the point of no return. The most energetic jets in the universe, streams of particles shooting out at near-light speeds for millions of light-years, are powered by the spin of black holes. Without spin, these cosmic engines would fall silent. The mystery of spin. But here's the deeper question. Why does spin exist in the first place? Why didn't the universe settle into stillness? Physics tells us that spin is conserved. It never disappears, it only transforms. But the origin of that first cosmic twist is more mysterious. Some scientists believe it was born from quantum fluctuations in the earliest fractions of a second after the Big Bang. Others suggest spin is woven into the fabric of reality itself, a property of matter as fundamental as mass or charge. What we do know is that spin is universal. It doesn't matter where you look or how deeply you zoom in. Whether it's the whirl of galaxies, the twirl of hurricanes, or the quantum spin of electrons, the universe insists on motion. Stillness, in the absolute sense, may not even exist. Spin and time. There's also something poetic about spin. It connects directly with time itself. A planet's spin defines the rhythm of days and nights. The Earth's slow wobble and tilt shape the rhythm of seasons. The spin of pulsars, neutron stars rotating hundreds of times per second, acts as some of the most precise clocks in the cosmos. In a sense, spin is how the universe keeps time. Without rotation, there would be no sunrise and sunset, no tides, no heartbeat of days. The very cycles of life depend on the steady, endless turn of worlds. The universal dance. Step back and a pattern emerges. The smallest particles spin. The largest galaxies spin. Everything in between, atoms, storms, planets, stars, and black holes, joins the same cosmic choreography. Spin is not random. It is the universal dance, connecting the invisible quantum world with the grand sweep of the cosmos. It gives order to chaos, rhythm to existence, and balance to reality. Without spin, the universe would collapse into something lifeless, unshaped, and still. With spin, the universe sings. Imagine the early solar system again. A cloud of gas and dust collapsing under gravity. As it shrank, it spun faster, flattening into a disk. From that swirling disk, planets formed. Even today, the echoes of that ancient spin are preserved in the rotation of Earth, Jupiter, and the rest of our neighbors. But here's the twist: spin is not perfect. Collisions, impacts, and chance encounters shaped each planet's unique rotation. A massive object may have slammed into Venus, slowing its spin and flipping it backward. Uranus likely suffered a colossal impact that tipped it on its side. Our own moon was born out of a violent collision, forever altering Earth's rotation and stabilizing its tilt. Spin, then, is not just inherited. It evolves. It is written by history, by accidents, by the scars of cosmic battles. Every spin tells a story of survival. Spin as structure. Look closely at galaxies and you'll see a beautiful spiral pattern, like a cosmic pinwheel. That shape itself is sculpted by spin. Without rotation, galaxies would simply collapse into featureless clumps of stars. Instead, their spin stretches matter into graceful arms. Our Milky Way is one of those spirals, and it is spinning right now, carrying us with it on a journey that will take hundreds of millions of years to complete one turn. Even elliptical galaxies, which lack defined arms, are shaped by the rotation of stars within them. Spin is what gives galaxies identity, structure, and order. Without it, the night sky would look unrecognizable. No spirals, no pinwheels, no graceful arcs of starlight. Spin and magnetism. Spin also gives rise to one of the most important invisible forces in our lives: magnetism. The magnetic field of Earth, generated by the rotation of molten iron deep within its core, shields us from deadly solar radiation. Without it, life on our planet would be fragile, if not impossible. Zoom down to the atomic level and the story repeats. The spin of electrons inside atoms creates tiny magnetic moments. Collectively, these spins align to form the magnets we use in everyday life, from refrigerator doors to powerful MRI machines in hospitals. Entire industries and technologies depend on the ability of electrons to spin in harmony. It's as if the universe is constantly whispering. Spin is not just motion, it is protection, energy, and possibility. The strange side of spin. Spin isn't always predictable. In the quantum world, it behaves in strange ways that defy our everyday understanding. Electrons can be up or down in spin, almost like tiny arrows pointing in opposite directions. But here's the strange part. Until we measure them, they can exist in a kind of superposition, both up and down at the same time. Even stranger, spins can become entangled. That means the spin of one particle is linked to the spin of another, no matter how far apart they are. Change one, and the other instantly responds, even if it's across the universe. Einstein himself was baffled by this, calling it spooky action at a distance. Yet this spooky spin connection is real, and it may one day power quantum computers that solve problems unimaginable for today's machines. Spin, then, is not only the architect of stability. It is also the key to mystery, unpredictability, and possibility. Spin across scales. The more we look, the more we see the same rule repeating at every scale. At the tiniest level, particles spin, shaping chemistry. At the human level, spinning turbines and wheels power civilization. At the planetary level, Earth's spin defines time, weather, and seasons. At the stellar level, stars spin, shaping their lives and deaths. At the galactic level, billions of suns swirl in spirals across the cosmos. It's as if the universe is fractal, echoing the same principle of rotation in different forms, from the unimaginable small to the incomprehensibly vast. A universe without spin. To grasp the importance of spin, imagine the opposite. A universe without it. Atoms without spin wouldn't bond. Molecules wouldn't form. Planets wouldn't rotate, leaving one side in eternal day and the other in eternal night. Weather, winds, and oceans wouldn't flow. Galaxies wouldn't spiral, they'd collapse into shapeless lumps. Even time itself, marked by cycles of rotation, would lose its rhythm. Without spin, the universe would be silent, still, and lifeless. Spin is what makes the universe dynamic, textured, and alive. The endless dance. And yet, spin never stops. The Earth spins as you read this, carrying you eastward. The moon spins, always keeping the same face toward us. The sun spins, driving the storms of its surface. The Milky Way spins, carrying us toward an eventual collision with the Andromeda Galaxy billions of years from now. Even if everything else fades, spin endures. Angular momentum is one of the few eternal currencies of the universe. It can be transformed, redirected, but never destroyed. Long after stars burn out, long after galaxies collide and merge, spin will still ripple through the cosmos. The universe was born spinning, it lives spinning, and it will die spinning. It is not an accident. It is the very fabric of reality. And so, the universe continues its eternal dance, from the smallest particles to the grandest galaxies, each one spinning in rhythm with a cosmic song that began at the dawn of time. If you found yourself amazed by this journey, stay with us for more stories that uncover the hidden patterns of existence. Make sure to like, share, and subscribe so you don't miss the next adventure into the mysteries of the cosmos.